So now we come to the fifth step in the process of cleaning and disinfection, the step of disinfection. In disinfection, there are a couple of things that are very important. The product itself, the chemical that we're using as disinfectant, of course is very important. But there's something else which I believe is perhaps as important or maybe more important, and that's the application method. So we're going to spend some time talking about the chemical, but we're also going to talk about the application method. When we talk about the chemical, there's a couple of things that we should keep in mind. First of all is the obvious. The chemistry should have a broad spectrum of activity and should have rapid action. Secondly, the chemistry should be safe to humans, safe to animals, and should be safe to materials. The third thing, the chemistry should be safe to the environment. A lot of the runoff and discharge from our operations ends up into natural bodies of water or into a wastewater treatment operation that depends on a biological flora. So it's important that the environmental impact of what we're using is minimized. When we think about the application of the disinfectant, we think about several things. The first one is contact time, of course. And related to contact time is something that I call cling time. This is particularly relevant to vertical surfaces. In other words, when we have a vertical surface, you can imagine that the disinfectant will run off due to the effects of gravity. And so, surfaces that are on the higher end of a vertical surface will not receive the same contact time as surfaces that are towards the bottom. So cling time, in other words, having the disinfectant remain on a vertical surface for the required amount of time is very important. This has to do with solution viscosity, and we'll talk a little bit more about that later. The other thing is that when the solution is applied, it should be easily visible. In other words, we can see very easily when we're applying the disinfectant, what surface has been treated and what hasn't. This avoids wastage of product. The third thing is that the concentration of disinfectant that we prepare should be easily validatable. In other words, I should be able to tell whether I have the right dilution, the right concentration of my active in the disinfectant while it's being used. This is very important. So when we talk about broad spectrum activity, we're talking about the ability of the disinfectant to destroy the different types of microorganisms that you can encounter in the environment. And a good way of looking at it is in the form of a pyramid of susceptibility, a hierarchy of susceptibility, if you will. So when you look at the pyramid, you can see that at the base of the pyramid, you have the easiest to kill organisms. Those are the envelope viruses. So things like PRRS and PEDV, those type of viruses, while they are very costly from a production point of view, they're relatively easy to inactivate from a disinfectant point of view. The next on the scale are vegetative bacteria. So things like gram-positives and gram-negatives, Staphylococcus, Salmonella, Escherichia coli, those type of things. Those are the second most susceptible organisms to disinfectants. The third on the scale are fungi. After fungi, we have non-envelope viruses, so small viruses that lack that lipid envelope. Typically, they're very difficult to kill. Things like parvovirus, for example. After that, we have mycobacteria, for example, the causative agent for tuberculosis. And then we have protozoa with cysts. And finally, the most difficult to destroy organisms are bacteria that are able to form spores. So any type of bacterial endospores, any type of Clostridium genus, for example. So the sixth step in the 7-step cleaning and disinfection process is the drying step after disinfection. Now, traditionally, this has been an important step because of the nature of the disinfectant chemistries used up to now. Why has that drying step been critical? It's been critical to avoid any type of adverse effects on the animals by bringing them in before the disinfectant has dried on the surfaces. Now, you can see that that can be avoided if the disinfectant being used is non-corrosive to skin or eyes. This is the case with accelerated hydrogen peroxide. By using accelerated hydrogen peroxide as a disinfectant, there is really no need for this 6th drying step. So the 7 steps are reduced really to 6.